Let's continue. In this lesson, we will create a central control for the lifting luggage example. By central, I mean a single controller running on a single device that controls the whole system, that is both the mechatronic units. Let's open the basic node. We see that there is a folder called model. This folder contains all the function blocks related to the model we saw in the last lesson. That's represented by this block. It is good to organize this way so we know which blocks belong to which part of the solution. Let's create a folder called control and we will put our controller blocks here. For now, there will be just one function block. Now right-click on the folder and add a new item. Let's call our controller Central Controller. How does its interface look like? It will be the mirror of the model interface. Input data becomes output data and vice versa. Let's create the interface for our central controller. First, the input data. All the data will use bool as the data type. Next, all the three outputs. Let's now create the required with associations as well. All the data will be associated with all the events. Now let's define our ECC. We will delete the request state as it's not needed. We will also remove the request algorithm. Let's organize a little and move to the center. Let's see what should be the initial state by examining our HMI again. The initial state is how the system should start for the first time. Suppose the system is in a state as shown here. When the lift cylinder is somewhere in between, we need to reset it so that lift starts in retracted position, so does the pusher. This logic will be added in the init algorithm. Once the system reaches the initial state, we can also move to the initial state in ECC. Let's create this state. How do we transition to this state? We transition to this state when we get request event and both the cylinders are retracted. Let's add an algorithm to execute in this state. There are two ways to add an algorithm. First is to go to the Algorithms tab and then add a new algorithm. The second way is from ECC. Add a new action and then click on the left box and select New Algorithm. What should happen in the algorithm? We need to set those actuators that we set to true in the last algorithm to false, which was retract lift. We will emit this CNF event when the algorithm finishes execution. Let's add the next state, which is lift luggage. Once the luggage is lifted and we need to push the luggage, and once the luggage is pushed, we need to reset everything and go back to initial state. Let's add an algorithm for the lift luggage. We will need to set extend lift to true. How do we transition to this state? We do so when the request event is received and the luggage arrives. Now we add algorithm for push luggage. Here, we first need to set extend pusher to true and extend lift to false, as it was set to true previously. And lift is a double acting cylinder as well. We transition to this state when cylinder lift is extended. As a safety check, we can also check for the luggage lifted to be true. to make sure luggage did not fall or there was no other error. Ideally, we need to handle such errors by transitioning to an error state, but we won't do that in this course. Next, we add algorithm for the luggage pushed state. We need to retract both the cylinders. Remember, pusher is a single acting cylinder. We need to set the actuation to false to retract. We transition to this state when we get the request event and pusher is extended. We then transition to initial state when we get the request event and both the cylinders are retracted. Let's build the solution and see if we get any errors. No errors are seen. That means we didn't make any mistakes. That's all for this lesson. In the next lesson, we will add this controller to the application and deploy and run it.